this will be actually good review for your finals, I think, just because you guys have done the processes before, but not involving an LN. Bless you. So this is a good review for like the process too, which you've already like learned. So hopefully it's not too terrible. Now, implicit differentiation was when you guys had things in two variables, where you had maybe like x's and y. Right? So everything wasn't taking the derivatives with respect to x. You might have had to take the derivative with respect to y in some things too. So the big thing with implicit differentiation was where you had to take the derivative of each side. That was like your first step. Take the derivative of each side. Right. And then the big idea, I know Matt and John, you guys were just kind of talking about it, right? When you take the derivative of y, so when take of y, right, we have to write dy dx. Okay. After. The idea is like the same thing. I just have found that the solving part to get dy dx alone is a bit tougher, just because you have ln's which make extra like fractions and things. So here's your first example. Example 1. You have ln of x, y plus 5x equals 30. All right. So in here, when you guys make it easy. All right, I did the same thing at first.
ln x plus ln.
Yes, Kyle, great. Okay, look for this with regards to your ln. Right, use your ln properties to make it easier. Because I did the same thing, and then I was like, oh wait, that makes it very, very complicated. All right. So to make it easier, right, ln x, because these are being multiplied, plus ln y. Now the rest of it's just going to stay the same for right now. Once we rewrite it and make it easier, now we need to take the derivative of x, like everything in here. So what's your derivative of ln x? Ln x, good. Right, this is where it gets a little complicated, right? To treat your y like the u. So what's your du? What would you have to write? What do you want to do? dy dx, good job. So we have dy dx all over, what do you think? Y, good job. Yep, yeah, because that is like your u. So it's u prime over u, but you have to use y. Now the rest of this is the same thing, just taking the derivative. So we should have 5 and then 0.
So can you turn that into dy dxy?
Wait, say it one more time?
Can you turn that into dy dxy?
No, because it would be like dy dx 1 over y. You know what I mean? If you separated it, it would be a little bit different. Okay, so a couple ways to solve this. Anybody have an idea how we're going to go to get wait, are we not going to use 5 over you say? Like for 5? Well, wait, well, is there ln there? No. That's only when you're taking the ln of something. So this part over here is just regular derivative. So, no, just get rid of that. What do you think, Sean?
Move the dy dx over y to the right, and then take or then multiply both sides by y.
Okay, we can try that, right? That sounds good. I did a little different. So you're saying move this over y. Okay, I'm going to bring this thing over here. Alright, so we have 1 over x plus 5 equals negative 1 dx over y. Alright. I think this is going to end up being kind of the same idea, hopefully.
What did you do for this?
I got a common denominator across the whole bottom and crossed it out. So, I think maybe Sean, you're kind of doing the same thing here. Okay, so what would you guys want to do now? Okay, so this one could be a y. Good. Well, are you trying to make a common denominator? Well, the way to like multiply all by y.
Throughout everything, you'll turn into y over x plus 5y equals negative dy dx and move the negative over. So you have dy dx equals negative y over x minus 5y.
Oh, I didn't think about it like that. Okay.
That's exactly right.
That's your, okay, I didn't think about it like that. I was trying to get a common denominator and just cross them out. Okay, let's see. Yeah. So you multiplied.
Everything by negative y.
Yeah.
Tricky.
And then the right side is just we go out.
Okay, yeah, that would work. I didn't think about that. That's good. Good job. Smart, good job. So this would give you negative y over x minus 5y. And then here, those are going to go under negatives to make a positive. Wow. And then dy dx is alone.
Yeah.
Good job. Good job.
Thank you.
Great work, Marty. Just to make sure, because like this is not how they left it in the back book, they might have like taken it to the next part. Just make sure you guys kind of get the idea. Like if you needed to get a common denominator, I think they left it like y plus 5y x over x, like that, and you factor out a negative, right? So just make sure you're like aware. You know, they might take it to the next step if they need to. You guys are so smart. Good job, Courtney.
You got it.
Good job. That was great. How did you guys do with like the implicit part? Do you kind of remember?
Yeah.
You kind of see why you have to alone? I'm curious how you guys are going to solve this next one because I thought this was.
Actually, I don't even solve it.
I mean, you didn't want to solve it.
No, I said I don't even have to.
Really? I mean, there's like lots of ways you guys could have done that. It's very like. Alright, here's your next one. It's softer. Yeah. Do you guys want to try this one on your own, or do you want me to kind of help you through it?
Did you go through it on me?
Did you write that on your own? I would rewrite things first, though, before you guys start doing the writing stuff. Yeah, rewrite that ln stuff. That was the best word. Yeah, so. I'll let you know if you do that, too. And then don't forget to do this part. Make sure you guys are rewriting this before you guys just go and take the derivative of everything. So 2 ln x plus ln y. Right. Just makes it so much easier. And then go for your derivative down both sides. Watch out in here if you're using something special to multiply. If anybody wants to try it up there, you want to get up and do it? Anybody like stuck that needs some help? Shift or doesn't want to go get their income?
and then first divide by y. And then I multiply the same by oh wait. So it's made 2x and we made 2y over x and make it 4y is 4y squared. Yeah, so subtract that. Oh, yeah. Okay, so I'm not done yet. Wait. Okay, it seems right now.
Okay.
2y. 4y squared over 4x
Oh,
over
no,
y.
that's your you want to get.
That didn't sound anything like my explanation.
I
So
think,
yeah, hers was still there, that's.
oh, okay. All right. I got negative 4xy squared minus 2y, and then over 4x squared y plus x.
Yeah, that's what I got.
Just put a different sign.
Yeah, I don't have the,
Listen,
I don't have the negative out.
Oh, yeah, totally fine.
If I have 2xy plus 1 on top and 4xy plus 1 on the
One
bottom,
letter off in here, I don't know where to figure out the
You're
rest.
supposed to know the part, but.
I know, mine was, so.
It's probably fine.
On next.
But you just subtracted one stuff out. And you got rid of 2y. Keep that there for again. I think I saw everybody at least like move like things over.
Oh, yeah, so the whole thing over x? Okay.
So we have what, negative 4y minus 2 over x. And then
So it's,
you guys got.
so I have 2y. I have 2y minus.
And you got to hear,
2,
did we all ever factor out, or some of you guys were at this step right now? If you want to keep going, like factor out the dy dx. So dy, yes, 4x. Watch out for this 1 over y. And then to separate, we got to divide by this piece. 4x plus 1 over y. Now we don't want to leave it like this, so clean it up. Make this x, x. Same thing like y, y. Alright, you don't want like all these like fractions over other fractions. Negative 4xy minus 2 over x. And then 4xy plus 1 over y. And then what did you guys have to do at the end? How to change flip, good. And then when you copy and flip it, it should be like nicer to deal with. At least you can get a single fraction on the top and bottom.
Extra x in my top fraction. Because I did
There's just a lot of spots to get like tricked with this stuff. So then just take this and bring it through. Same thing on the bottom. 4xy squared. And there's different variations, guys. Just if you had like all positives up here and all negatives up here, it's the same thing. It just matters like which way you brought things like across your equal sign. Okay, but they're equivalent. Okay, great job.
Yeah, see, I had an extra X in the bottom.
This is what makes sense.
Okay, I got one more like thing for you guys for today. Oh, Sarah, can you do that? Yeah, absolutely. Finding. This is also like a review thing, but it just has LN in it, so I wanted to make sure we kind of over it. Relative. Extrema. I hated this stuff. It's just long. It's just long. It's not hard. Do you guys remember when you're doing like relative extrema, that was like finding the max min, where you're increasing, decreasing, point of inflection? Yeah, there's a lot of stuff. So I just want to make sure we kind of like just do a quick little recap. When you're going to find a critical point, right, that's going to be where the derivative equals 0. So that's how we find our critical point. By setting the derivative equal to 0. Then to do your testing for like increasing or decreasing, what we have to do is we're going to plug into the derivative. You got to make like test points, right? So we're going to test into derivative. For your max min point, your x value, when you guys get your critical point, that coordinates with the max min. That's like the x coordinate. Do you remember where you plug the x in to get the y? Original, nice, good. Right. In original. There we go. Or y. And then the other thing that you guys are going to have is the point of inflection. Do you guys remember what derivative that is? Second. Oh, good job. Is where your second derivative equals 0. Okay. Good recap. So some of this is kind of a review for you guys, and it's been a long time since we've done this. So here's your first example. X minus ln x. Here we go. Right. So if they say like find the extrema, find min, max, or increasing, decreasing, first thing I would do is find your critical point. So we need to figure out the derivative where the x value is equal to 0. Like what will make the derivative equal to 0? Okay. So what's the derivative here?
1 minus 4x.
Perfect. Great. So let's set this equal to 0. To make it a little bit easier, yeah, good job. Get your denominator makes that x minus 1 over x. So if you want to see what's going to make this equal to 0, feel free to do your cross multiply. X minus 1 equals 0. Add your 1. So x equals 1 will make this thing 0. That part, good, bad, and that good. No, sorry. Alright, so that's going to be the x coordinate for the maximum point. No, you like, I don't know if you were confused or.
If you just added the 1 over x, it would.
That's true. That would have been way easier. Yeah. Yeah. Sorry. Sorry about that. No, that would work too. Good job. Now, when you guys did your tests into like the increase decrease, do you remember how to do your little pictures? Yeah.
Yeah, that ugly
Okay.
stuff.
So you took your x here. Now, there was also something else we needed to be careful of, and this is going to happen a lot when you're dealing with ln. What can you not take the ln of?
0.
0, good, or a negative numbers. If you guys tried to take the ln of 0, let's see, ln 0.
Non-real number.
Yeah, we get non-real numbers. Same thing to ln with anything that's negative, right? You can't do it. So,
You put in a negative, that's not real.
yeah, it does. So it's like,
Why don't you just take the ln of 40 and then negate it?
I don't want to do that though.
saying.
I'm sorry, what?
What?
I don't know what that means. 1 second. So I just want to make sure that you can't say
Like when you take the square root of a negative number, like negative 49, it's 7i. So that means that we just take the natural root of
Still
an odd number. So it'll be whatever that is.
Maybe not.
I don't know.
You know what I'm saying or no?
Yeah, but I don't know if you can do that with Ellen though. I don't know if you can apply those to the rules. I don't know. I'm sure. Sorry. Here's the reason why I brought that up. Is, do you guys think then you can exist at 0? Because we're dealing with something like our ln. If you guys try to put like 0 in here, 0 minus the ln of 0, this would give you like an error. It wouldn't work. So when we do our testing, we're going to have a asymptote, a vertical asymptote there. And if you're not sure, pull up your graph. And y equals, if you weren't sure, x minus ln. Oh gosh, there we go. Okay. So see how it doesn't go past this? If you did your table, you get all the errors, 0, negative.
Error.
Yeah, I'm going to look what you're talking about and see if we can do it. Okay. So that just means we can't exist there. So when you guys do your test points, when you pick something to the left of 1, you can't pick like 0 or negative 1 because it's not going to work there. What would you guys want to pick in here to test? 0.5 sounds good. Alright, so let's test out like 0.5. And when you guys do your testing, make sure we're going into the first derivative. So I would go into this like, this one maybe, this is kind of a nice looking piece, I guess, to use. So 0.5, you can put that in for our x. 0.5 minus 1. Did you guys get something negative? Remember, we don't care what this is, we're just looking for positives or negatives. Okay, so here we were decreasing, so we're going down, we're hitting this, we're going to see what's happening. Okay. What do you guys want to plug in there?
1/2.
1/2? Sure, 1/2, 2. Anything that's bigger than 1 will work. Okay, so let's plug something else in. I'm going to be lazy and pick 2 just because it's easy. Okay, so if you said 2 minus 1 is 1 over 2. Good. So that's still going to be positive. Okay. Alright, so that means we're going to be increasing here. What can we say about this point, this, well, at 1? Is it going to be a max or min? Min, because it's on like the bottom of something. Because we have min point, minimum at 1. Oh gosh, we need to find the y coordinate. Where are we going to go? Where's the original? Good, okay. No, alright. Okay, so let's plug 1 in here and see what we get.
I get 1 minus 1, 0.
Good. Yep. Nice. Remember the ln of 1 is 0? Maybe it's not, you can calculate it. Okay. So we got our minimum, we know where we're decreasing, increasing, decreasing. The last thing I just wanted to make sure we knew how to do, if you wanted to do the point of inflection, and you got to get y double prime, this is really why you would want to make sure your single prime looks nice, and so then you can get to your double prime pretty quickly. So make sure it's all like compacted into like a single fraction if we can. So if you guys took this, oh nice Kyle, we haven't done this in so long. Good job. Yeah, we gotta use quotient rule. If this is y prime, I know. I thought it was just a good little review day. The whole
times
you
1
hated it. Sorry, Sarah.
Okay, no,
minus
I didn't do it.
1. So actually,
Sarah, I hate it. Courtney.
it's just going to be negative 1 over x squared.
What? You keep going, Taylor. So, you're right.
Or no, 1 over x.
Just make sure you guys distribute this through. Oh my gosh, alright. Can you guys set this to 0? Will anything make this 0? No. Okay, so can the point of inflection exist? No.
Yay.
So here, there's going to be no POI. Okay, because nothing will make this 0. It doesn't work.
Oh boy.
Great job. Okay, so here's your homework. On page 332, 83, 85, 91. You only have 3 questions.